All right. So today we are looking at special right triangles. They are special. And they're special because of their angle measurements. We got two different types of special right triangles, either a 45-45-90, in other words, two 45-degree angles and a 90-degree angle, or a 30-60-90 special right triangle, which would be a 30-degree angle, 60-degree angle, and 90-degree angle. And because of those angle measures and the resultant side lengths that you get with those angle measures, there are set criteria or set formulas we can use if we know one side length to find the other side lengths of a special right triangle. So theorem 9.8 for a 45-45-90 special right triangle tells us that the hypotenuse is the square root of 2 times as long as each leg. So if we look here, got a 45-45-90 right triangle, which would also be an isosceles right triangle. So the two legs are going to be the same length, so they're both x values, or whatever number we have there. And then to get the hypotenuse from the length of the legs, we just multiply the length of the leg by the square root of 2. And then for a 30-60-90 special right triangle, the legs are different lengths, and basically everything, all the other sides are based off of the short side, or the short leg of the right triangle. So the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. So if I know what the shorter leg is, then I can multiply it by 2, and that'll give me the hypotenuse. Or I can multiply it by the square root of 3, and that'll give me the longer leg, or the leg that would be opposite the 60-degree angle. So hypotenuse, 2 times the short leg, longer leg, square root of 3 times the short leg, or 30-60-90. And then the square root of 2 times the leg gives you the hypotenuse in a 45-45-90. Right. So here we have two different 45-45-90 triangles. And the first one, we're solving for the x, which is the hypotenuse value. And they gave us the length of the legs. So that makes finding the hypotenuse value pretty easy, because we know that I just take the leg and multiply it by the square root of 2, and that gives me the hypotenuse. So the x value is going to equal the square root of 2 times one of the legs, or rearrange that so it's 5 square roots of 2. So then the next example is a more difficult version, because in this case they gave us the hypotenuse and we're solving for the legs, which they're both listed as x because they're going to be the same. And the one thing that I know is the hypotenuse, which is 12, is supposed to be equal to the square root of 2 times leg, square root of 2 times x. And so to get the x by itself, we divide by the square root of 2, and we get 12 over the square root of 2. Anybody know the problem with that? All right, mathematically incorrect to have a radical in the denominator of a fraction. So before we can call it finished, we have to adjust that answer so that there's not a radical in the denominator. And so with the square root, in order to get rid of a square root, we have to multiply that square root value by the exact same square root. Or so I'll multiply by the square root of 2, and whatever I do to the bottom, in order to maintain the same fraction, I have to do the top. So that's going to give me 12 square roots of 2 over, take the square root of 2 times the square root of 2, just gets rid of the square root and gives me 2. And then I can do one more thing to simplify it a little bit, and that is 12 over 2 divides by 2 to give us 6 square roots of 2. Questions on that? All right. So that's a 45, 45, 90. Now for a 30, 60, 90. This one we are given the longest leg, and we're trying to solve for the short leg and the hypotenuse. So in a 30, 60, 90, in order for me to figure out the hypotenuse, I have to first figure out what the short leg is, because the hypotenuse is 2 times the short leg. So given the long leg, I have to find the short leg to get the hypotenuse. If I was given the hypotenuse, I would still have to find the short leg to find the long leg. Right? So that short leg is kind of the key to the answers for everything. So starting off, since they gave us the long leg, and we know that the longer leg is equal to the square root of 3 times the short leg, I can say 18 is equal to the square root of 3 times the short leg, which is the x. And that's kind of like the last example we did. We're going to divide both sides by the square root of 3, which 18 over the square root of 3 is technically the answer, but we can't leave it that way. Have to get rid of the radical out of the denominator. So since it's a square root of 3 in the denominator, we're going to multiply the top and bottom by the square root of 3, which will become 18 square roots of 3 over 3. And 18 divides evenly by 3 to give us 6 square roots of 3 for the short leg. And now that we have the short leg at 6 square roots of 3, now we can figure out the hypotenuse, which the hypotenuse is just 2 times the short leg. So our y value is going to be 2 times 6 square roots of 3. So y is going to be 12 square roots of 3. And the next one, an easier version, because they gave us the short leg and we're using it to find everything else. So our y value, or our hypotenuse, is just 2 times the short leg, 2 times 10. So the y value is going to be 20, and the x value is the square root of 3 times the short leg, which is 10. So that gives us 10 square roots of 3. So much easier if they give us the short leg first. Same thing on the 45, 45, 90s. If they give you the leg length and the hypotenuse, is pretty easy. Not that any of these are really crazy difficult. Tomorrow when we go over multi-steps, it gets a little more difficult. We'll hold off until tomorrow on that. Questions?